So let's start on this section 1.3.3, where we have all our tiles and we want to now clip it to this very complex looking polygon. So we're going to use the GDAL command to say I have a VRT and I want to clip it to this particular shapefile. Let's take this command line and start running it on the command. So copy this, and in the name folder that we already have, copy this and then start this command. This takes a few minutes. So as the command starts running, I'm going to explain what the command is doing in the background. So my processing is happening. As I explain, let me explain what we're doing. We want to clip this data to a particular region. There are two ways to clip data using GDAL. If you have just a bounding box, you say I have to take my larger raster and select a bounding box subset of this, we can use the GDAL translate command. The GDAL translate command has this options, srcwin and projwin. So srcwin says source window, projwin says projected source window. Here you can say, I have my source image, maybe a 10,000 pixel by 10,000 pixel. I want to select the rows from 5,000th column to 8,000th column to 5,000th row to 8,000th row. You can specify the row and column bounding box, and just go to select that and clip the data set to that. Most likely, you want to specify this data into coordinates. So you can say, this is the upper left X, upper left Y, lower right X, and lower right Y. You can specify those coordinates, and GDAL Translate will clip the data to that bounding box and save the output. So this is useful where you just say, I have larger raster, I have a bounding box, and I want to clip to that particular bounding box. If you want to now clip it to a more complex region, like a shapefile, we have another command. Another very useful command is this command called GDAL warp. GDAL warp is the utility that is used mainly for reprojection and warping, so resampling. This has an option called -cutline. So GDAL warp has this option called cutline, where you can say, take any OGR supported data source, so any vector data set. You can take a GeoJSON file, a shapefile, any other file that is supported by GDAL, and use this as an input to clip your original data sets. So bounding box, you can use GDAL Translate. For doing more complex clipping, we can use this GDAL warp with a cutline option. When you run this cutline, by default, GDAL warp will say, I'll take the input data and I will save this cutline within the file itself. So you will get the whole raster, and in the metadata, you'll say, oh, this raster can be cut to this cutline. It won't actually cut it. It'll just say, I'll take this cutline, save it into the header of this file. And there's another option called crop to cutline. Crop to cutline will say, whatever cutline you have, crop it to that. So why would you give these two options? What's the use of having a cutline in the file itself? Well, this is quite helpful in some situations. Let's say you are a map that you have produced. The map has some area where you have the actual data, and you have some title and legend and all of this outside of the map. You want to share the whole thing with the people who want to just look at the map. But then you say, I have this file, this has got the data in the middle. This is where the actual data is. So if you want to remove all the cartographic stuff from this and just use the data, I'm going to store the cutline into the header. So you get the GeoTIFF file, which is all the stuff, but I have a cutline stored in the header. So if you just want to extract the valid part of the image where there is data, you can use this option, crop to cutline. This is typically, I've seen it used in the USGS topographic maps. If you download the maps, they distribute it as GeoPDF files. These are actual maps with all the stuff, but in the middle, there's actually the data, which is a georeference data that they have. So you can say, crop the cutline, the actual cutline is saved into the file, and you can just extract that and then use it in your GIS. So sometimes it's useful. For us, we just have imagery. We just actually want to crop it, so we specify both. We say, cutline is this, and crop it to that. So let's see the command that we have. So we said GDAL warp. This is the AOI.shapefile. This is the polygon cutline we want to use. Crop to cutline, take the VRT file and create AOI_cut.tiff and apply your standard lossless compression, deflate with tiling, yes. Let's look at our output file. you'll see that this one is a 400 megabyte compressed GeoTIFF file. Okay, let's do GDAL info on that. So again, we have our extra band that we are carrying around for our mask, and we have this mosaic. You would think that, okay, we are done. We have cropped this. We have this 500 megabyte compressed file. We should be able to look at that. So let's try to see this in QGIS. So I have this AOI.cut. I'm going to load this. I'm loading this, and again, it keeps, loading. It doesn't load. So QGIS is decompressing this file, trying to render the 60 centimeter imagery. We have this data, which is 20,000 pixels. And again, just decompressing this, taking a long time. It's not able to display that because it's trying to display this at the full resolution. So let's not do this. I'm going to teach you the better way to do this. So again, we don't want to preview it yet. I want to show you an improved version of this. This is an imagery data. We can actually achieve much better compression. Remember, our source data was in JPEG 2000 format. So JPEG compressed format. That was much more efficient. And since this is an imagery data, we can go and say, I'm okay to tolerate certain loss of data, but I want to compress it better so I can store this more efficiently. Let's apply a JPEG compression. We will learn how to do this the most efficient way. So we can say compress JPEG. So that's the option we'll change from compress deflate to compress JPEG. We'll keep it tiled. There's this another option called photometric CBCR. If you read this post, which is linked from here, it says, how do you store the color information within the file? You can store it as RGB value, or you can store it as YCBCR transformed values. Apparently, using this saves more space. It compresses better. So for JPEG data, you can use this option, which will compress much better. JPEG quality, 75%. So we can increase or decrease depending on your requirement. And when we are doing JPEG, JPEG has no idea how to work with 4-band files. That's what we saw earlier. So we have to say, take the first 3 bands, the 4th one is a mask. This is important because if you don't do this, it'll say, oh, I have this file, some values are 0, which is outside the region that you clipped. And when it tries to compress all of that, you'll get artifacts. So let's first run it. And while it's running, I'm going to show you what if you do not give the mask here. So we'll keep our AOI file. I'm going to take this AOI cut, which is our lossless compressed GeoTIFF file. We're going to take it and compress it using the JPEG compression using these 3 bands. Copy the wrong command. Yeah. So while it's doing this, I want to show you why we need to have this mask and why we need to maintain this. If you just compress it using JPEG without any mask information or no data information, this is what you'll get. You'll get a mosaic that looks like this. If you work with aerial imagery, drone imagery for a long time, you would have noticed imagery that looks like this. These are called JPEG compression artifacts. What happened here was, since this is 0, this is non-zero, when you compress it, some of the 0 values become like 1 or 2 because it was compressed as a block, and JPEG decided that I can make it more efficient by storing that as a non-zero value. So some of the zeros will become non-zero and you'll get this artifacts. You see it quite often with people who have processed this data without really knowing what they're doing, or simply their software didn't support some of those masking options. We used to call this Smurf turds. So we'll see a lot of this Smurf turd imagery there. So if you have this imagery, it's already done that, the damage is already done. GDAL gives you this command called near black, which is another utility that comes with GDAL, which can clean up some of those. So if you have imagery with this JPEG artifacts, you can use the near black command, but we will process it in the correct way so we avoid this artifact. So if we have this mask band, the mask band will hold the right information. Mask band won't be compressed with JPEG. The real data will be compressed, and mask band will say, I will do a clean cut line around my region so I don't get this artifacts. We still cannot see the output. We have this AOI.TIFF. You can see that the resulting AOI.TIFF is 29 megabytes. See the difference. From 400 megabytes, we could now get to a file which is 29.1 megabyte. We lost some quality, but we achieved a huge saving in compression. If you compare the quality, visual quality, you won't see much difference because JPEG is very good at kind of preserving good visual quality between those. Many of you are keen to look at what this thing looks like. Please hold on. Even if you load this, QGIS won't be able to decompress and show you in time. Even if you let it do it for maybe 10 minutes, it'll do it, but I'll show you a much better way. So we'll see it soon, but this is what we did. We took our original VRT, converted it to a TIFF file, making sure we cut it and preserve the mask, and we applied JPEG compression to it.